This video is about metabolism of acetylcholine in the synaptic cleft and cholinergic receptor types and distribution. Now, this is the metabolism. Of acetylcholine. This picture or this video part is about metabolism of acetylcholine. How it is done? It is by hydrolysis. So, which is doing the hydrolysis? It is acetylcholine esterase. Acetylcholine esterase enzyme. This particular acetylcholine esterase enzyme is used in deactivating acetylcholine. How this is the black one is acetylcholine esterase enzyme. This is having serine moiety, tryptophan moiety, phenylalanine, glycine and histamine residue. So, this is histamine, glycine, this is phenylalanine, tryptophan, serine. So, all these amino acid is creating a packet for acetylcholine. This is acetylcholine. This is the cationic site. This is the ester site. Ester, cationic or otherwise ammonium site. So, this is separated into choline and acetic acid or acetate. The first step in the hydrolysis of acetylcholine esterase is forming a reversible complex. Then the second step is acetylation of esteratic site COCH3 is acetylated. Then hydrolysis of acetylated enzyme and finally free enzyme is produced. So, this is the acetylcholine esterase enzyme and inside that you have acetylcholine. So, this acetylcholine is first acetylated enzyme removes this acetate part. See this here, acetic group is taken by enzyme. The serine moiety takes up the acetyl group and it becomes acetylated enzyme. Acetylcholine becomes choline and this acetyl group is given to enzyme and therefore this acetyl group given to the enzyme must be removed and that too with the help of glucose or glutamine, and it is with the help of glutamine and the histamine. Originally serine was having acetyl group, and that is with the help of histamine and glucose, the acetate is removed from this enzyme. The enzyme, or in other words, enzyme gets acetylated and then finally deacetylated. So first one is acetylation of enzyme, and then last step is deacetylation. So that leads to the free enzyme production, and then choline is produced. So the produced choline is transported back to the synapse. So this is our original synapse, wherein you can see here the acetylcholine is esterase, hydrolyzed by esterase, acetylcholine esterase enzyme, which is present here. And that converts into acetate and choline. So acetate first combines with enzyme and then later removed from enzyme, and choline produced is transported via a choline transporter back into the synapse nerve endings, and again combines with acetyl coenzyme A with the help of choline acetyl transferase, and it is stored in the vesicle. So this is the metabolism of acetyl choline in the synaptic cleft. The cholinergic receptor is found to be of two types. So one is considered muscarinic and another one is considered as nicotinic. So what is this muscarinic and nicotinic? So muscarinic is the muscarine alkaloid, when given, selectively binds to certain types of cholinergic action receptors. So those receptor which is bound with muscarine are called muscarinic receptors, and they are 5 types in nature, M1 to M5. And the nicotinic, that we shall see later. The nicotinic is in neuromuscular junction and neurons, or the preganglionic. So NM and NN, two types of nicotinic. So these are the receptor subtypes which is bound because of nicotine, When it comes to muscarinic, the first one is M1, and it is GQ protein, and it is located in CNS, gastric intestinal tract, salivary glands, autonomic ganglia and trach nerves. Similarly, M2 is present in presynaptic nerve terminals, autonomic nerve terminals, CNS, heart and smooth muscle. Mostly this is muscarinics are present in smooth muscle, that is gastric smooth muscle, heart smooth muscle and smooth muscle. The next type is M3 GQ protein, M5 GQ protein. So this M3 is present in CNS, smooth muscle, glands and heart, whereas M4 receptor is of GI protein and it is present in CNS only. Similarly, this M5 receptor is present in CNS, predominantly muscarinic acetylcholine ganglions and dopaminergic neurons, substantia nigra and ventral tegmentum. This nicotinic receptor in the neuromuscular junction and one more area, it is in autonomic ganglia. The one that is found in neuromuscular junction is mentioned as N1 and it is autonomic ganglia is mentioned as N2. Sometimes muscular and neurons, NM, NN or otherwise N2, N1. So these are the subtypes of nicotinic receptor. Why this is called nicotinic receptor? Because the substance nicotine alkaloid is having its binding capacity at these receptor subtypes. So that is why it is called nicotinic receptors. Now it is a neuromuscular junction subtype nicotinic receptor. They are innervated at skeletal neuromuscular junction, post junction and somatic. Their main cause is excitatory, depolarization and contraction. So mechanism involved is sodium and potassium permeability increased and produces this contraction and excitation. Then ganglion neuronal ganglions, NN, and sometimes it is N2, sometimes it is called N1 or M, and this is neuronal. So this is present in autonomic ganglia and adrenal medulla. It causes excitation, depolarization, secretion of catecholamines, and this is also functions by sodium and potassium permeability. Now the receptor distribution. So the receptor distribution M1 is distributed in CNS, gastric and salivary glands and autonomic ganglia and enteric nerves, and it is innervated, it is acting through GQ protein, whereas M2 receptor is GI and GO protein. It is present in nerve terminals, CNS, heart and smooth muscle. Now the M3 and M4, M5 receptor. M3, M4, M5 receptor. They are innervated by G protein of Q subtype. It is present in smooth muscles, glands and heart. CNS is the area where you can find M4 receptor and it is GQ. So wherever you find the GQ subtype, they are M1, 3 and 5. Whereas for M2 and M4 you can see GI subtype. So this is the similarity you can find. M2 and M4 are similar, and M1, M3, M5 are similar in nature. This M5 is present in periphery muscle system or periphery organs, and they are muscarinic acetylcholine receptors. It is present in substantial nigra and ventral tegmentum.